Welcome to the Planet of Maths channel. In today's episode, we'll be calculating logarithms, and these will be the most basic examples. We have the definition of a logarithm here. In this logarithm, this number at the bottom is called the base of the logarithm, and this number b is the number being logarithmized. And in the examples, it has to be such that numbers a and b are both positive, and this logarithm-based number, it can't be 1. And it will work like this. This is called the base of the log, and everything is related to exponents. The base of the log, raised to this power, which is the result of the log, that is a to the power of c, must give us the result b, the number being logarithmized. This is how it is with letters, but let's look at a specific example now. The first example is a log base 2 of 16. What will be the result of this log? The number 2, which is the base of the log, this 2, to what power to raise, so that we get 16, and it turns out that the number 4 suits us here. If we take this number 2 from the bottom, and we raise it to this power of 4, that is 2 to the power of 4, we should get this result, which is 16. 2 to the power of 4, this is exactly 16, so the result of this log is number 4. The second example is the log base 3 of 9. We have to raise 3 to some power here to get the result of 9. The number 2 will fit us here, since when we take the base of the log and raise to this power, 3, which was the base of the log, is also the base of the power. We take 3 to the power of 2 and get a result of 9 from this. So here everything suits us. 3 to the power of 2 equals 9. Third example, the log base 5 of 125. 5 to what power to get a result of 125? Here we fit the number 3. 3 suits us because if we take this 5 from here, we raise it to this power, which means 5 to the power of 3. So we will get this result, which is 125. Next example, we have such a log, and here we do not see what is the base of this log. In such a situation, the default base here is 10. So if there is nothing in the base of the log, you have to know that the number 10 is in this base. We just don't write it. So we need to take the number 10 and raise it to some power to get 1,000 from it. And the number 3 fits here, because when we take 10 to the power of 3, it turns out to be 1,000. This invisible 10 raised to the power of 3 gives the result 1,000. Another series of examples, we are still in basic examples. Now we have the log base 3 of 81, so we need to figure out this base number, which is 3, to what power to raise it to get the result of 81. And here the number 4 suits us. That's because if we take this 3 from the base of the log and we raise this 3 to the 4th power, we get this result, meaning 81. Next example, log base 6 of the number 216. 6 to what power gives us the result 216? 6 to the 2nd power is 36, so 2 is too little. Number 3 will fit here. That's because 6 to the power of 3, which is 6 times 6 times 6, gives us exactly the number 216. The log base 7 of 49 will be such a number that when 7 is raised to this power, we need to get 49 out of this. 7 to the power of 2 is 49. Here's the explanation. 7 squared equals 49. Therefore, the result of this log is 2. The log base 2 of 64. Here you need to know the powers of the number 2, and you need to know 2 raised to what power gives us the result of 64. It turns out that 2 to the power of 6 gives the result of 64. Here we have an explanation. The number at the bottom, the base of the log, raised to this power, that is 6, it must give the result 64. Here we make a circle. 2 to the power of this gives us this result. The log base 3 of 243, well, it must be such a number that if I raise 3 to this power, I will get the result of 243. The result of 3 to the power of 4 is not enough, because 3 to the power of 4 equals 81, we have it here. The number 5 will fit here. Since 81 times 3 gives us 243, or in other words, 3 to the power of 5 is 243. So the result of this log is the number 5. Now a series of special examples. We have log base 7 of 7. This 7 from the bottom has to be raised to some power, and we need to get 7 from it. So 7 raised to the power of 1 gives us the result 7. 7 to the power of 1 equals 7. Here it will be similar. We have to raise the base of the log to some power to get this result 5. 5 to what power does give us 5? 5 to the power of 1 gives us the result 5. 5 to the first power equals 5. The log base 2 of 1. Now it has to be so that the number 2 raised to some power must give us the result of 1. And that happens when we have 0 here. The number from the base of the log, that is 2, raised to the power of 0, gives a result of 1. So this number from here, raised to this power, gives this result. Now it's probably going to be the same because we have 17 as the base of the log, and the result should be 1. So 17 to what power gives the result of 1? 17 to the power of 0 equals 1. Here we have it written down. So the result of this log will be 0. Some examples with fractions. Log base 9, and the logarithmized number is 1/9. In such a situation, we need to raise the number 9 to some power to get a result of 1/9. And here we have to go into negative powers. The result of this log will be -1. To raise this 9 to the power of -1, we need to remind how a negative power works. If we don't have fractions here, it works in a way that we write 1 at the top, and at the bottom we only give it, but without the minus. So here we have 9 to the power of 1. 9 to the power of 1 is 9. Here it comes out 1/9, which exactly means the result of 9 to the power of -1 gives 1/9. Another example is the log base 1/3 of the number 1/9. 1/3 raised to some power gives us 1/9. And if we raise 1/3 to the second power, we get the result 1/9. Here we have it spelled out. 1/3 to the power of 2 is 1/3 times 1/3, which is simply 1/9. So the result of this log is the number 2. In the next example, we have log base 25 of the number 5. Here we have to raise the number 25 to some power to get a number less than 25, which is 5. Here it's going to be weird again. Knowledge of rational exponents, meaning fractional ones, comes in handy here. The result here will be 1/2. And this is because if you take 25, which is the base of the log, raised to the power of 1/2, how does it work? If we have a fraction in the exponent of powers, we will definitely get a root. This root is the degree of what's in the denominator. So this 2 is in the degree of the root. This is a second degree root, or simply square root. And under the square root, there is this number 25. Raised to the power of this one in the numerator means to the first power. But such operation is just a simple square root of 25, because we never write this 2, and we don't have to write this one in power either. The square root of 25 gives us the result 5. So this is the number we wanted. That's the logarithmized number. 25 raised to the power of 1/2 gives a result of 5. So the result from this log is 1/2. Log base 4 of the number 1/4. The number 4 from the base of the log we have to raise to some power to get a result of 1/4. To what power do we need to raise it? It's enough to raise it to the negative power again, to the power of -1. And that's because when we take the log's base 4 and raise it to the power of -1, this minus tells us that we have a fraction here. 1 goes up, and everything that was here goes down, but without the minus, which means 4 to the power of 1. And this is exactly 1/4, so this number from here. 4 raised to the power of -1 gives the logarithmized number 1/4. And the last two examples, log base 4 of the number 1/16. To what power to raise the number 4 to get the result of 1/16? In this case, the negative powers will prove useful. 4 to the power of 2 would give us 16, and to get 1/16 here, it has to be -2. We're checking this out. We take the base of the log to the power base and raise it to the power of -2. How does that work? Since there is a minus here, a fraction bar appears and 1 appears on top. And at the bottom should be this, but without the minus. So there's 4 to the power of 2. If we calculate 4 to the power of 2, we get results of 1/16. That is the result. This means that the number 4, the base of the log raised to the power of -2, gives the result of 1/16. Thus the result of the log is -2. The last example, log base, we can't see what it is, but we already know if we can't see anything, it means that there is an invisible 10 of the number 1,000th. To what power should we raise the number 10 to get 1,000th? 10 raised to the power of 3 gives us 1,000. Therefore, the conclusion is that it's going to be something related to a number 3. But for a fraction to appear, there must also be a minus. The result is negative 3. This is confirmed by such operation, an invisible 10 raised to the power of minus 3. We're operating in a circle again. This 10 to the negative third power should give us this result, and we'll check it right away. 10 to the negative third works like this. There's a minus, there's a fraction. At the top, there must be one. At the bottom, we put what was here, but without the minus, so 10 to the third power. And if we calculate 10 to the power of 3, well, it gives us 1,000, so we have here 1,000th. This is exactly the result. So the result of this entire logarithm is the number negative 3. And that's all for this video. Thank you for watching, and I invite you to tune in for the next episodes on the Planet of Maths channel.